You know that feeling in a system design interview where you wonder if it's just a big test of who can name the most buzzwords? Well, we're going to throw that idea out the window today. We are going to break down what technical excellence really means to an interviewer and how you can show it to absolutely crush that conversation. So let's dive right in. This right here, this is the core idea we have to get in our heads. See, interviewers aren't just looking for you to rattle off a list of technologies you know. They're digging deeper. They're testing if you really get the fundamental principles that make any big system work. It's all about showing that you know this stuff so well you can tackle any problem they throw at you. And here's what that looks like in practice. A junior level answer might just name drop a tool. Yeah, I'll use Kafka. But a senior answer, it frames the whole thing as a trade-off. It's not just about knowing what Kafka is, it's about explaining why you'd pick it over something else and tying that decision right back to what the system needs to do. That's the mindset we're going for. All right, so here's our game plan for today. First, we're going to figure out what interviewers are actually looking for. Then we'll get into the absolute must-haves, designing for scale and reliability. After that, we'll hit the most important part, the art of the trade-off, and we'll wrap it all up by showing you how to talk about modern tech to bring it all home. Okay, let's just get one thing straight. The final diagram you draw on the whiteboard, it's probably the least important part of the whole interview. Seriously. What interviewers really want is to see how you think. They want to hear you ask questions, figure out the constraints, and justify your decisions every single step of the way. So at the end of the day, technical excellence is this beautiful mix. It's about proving you have a rock-solid grip on the core principles of distributed systems, but also showing that you know how to actually build things with the tools and patterns people are using in the real world right now. Okay, now let's talk about the bedrock of any good system design: scalability and reliability. These two are completely non-negotiable. I mean, if your system falls over when it gets popular or crashes every time one little thing fails, then nothing else matters, right? This is absolutely table stakes. First up, we've got scalability. And what does that really mean? It's just your system's ability to grow. If your traffic suddenly doubles, can you throw more resources at it and have it just work without slowing down to a crawl? Believe me, this is one of the very first things an interviewer is listening for. This is a pretty classic picture of a scalable setup. You've got a load balancer, right, spreading traffic across a bunch of application servers. And the key word here is stateless. That's huge because it means any server can handle any request, which makes it super easy to just add more servers. Then you've got a cache to take some pressure off the database, and the database itself is split up or partitioned to handle tons of data. And finally, a message queue to handle heavy background jobs without slowing things down for the user. Now, a huge part of this scalability conversation is vertical versus horizontal scaling. Think of vertical scaling as just making one server more and more powerful. It's simpler, but you're going to hit a wall eventually. Horizontal scaling, on the other hand, is about adding more servers. Yeah, it's more complex, but it's how all the big modern systems are built, because you can basically grow forever. And now for scalability's best friend, reliability. This isn't just about being up and running, it's about designing a system that expects things to fail. What happens when a server dies or a whole database goes offline? A reliable system is built to handle that stuff gracefully and just keep on working for your users. So how do we actually do that? Well, it all comes down to getting rid of single points of failure. That means you've got backup or redundant instances for everything important. It means your load balancer is smart enough to stop sending traffic to a server that's died, you've got automatic failover for your databases, and you're copying your data across different physical locations, availability zones. So even if a whole data center has a problem, your system doesn't skip a beat. All right, pay attention, because this next part is without a doubt the most important section. If you want to scream seniority in an interview, this is it. We're talking about the art of the trade-off. Because in system design, there's no such thing as a perfect answer, just a series of really smart compromises. This quote just nails it. It gets right to the heart of everything. Look, anyone can memorize the architecture for designing Twitter, but only someone with real design maturity can talk about why they picked one database over another, or why they choose availability over consistency for a certain feature. This is where you show the interviewer how you think, not just what you've memorized. So let's take the classic trade-off from the CAP theorem. Do you want consistency or do you want availability? Think about a bank. You absolutely need consistency, right? You can't have two ATMs showing different balances. You would much rather the system be down for a minute than show the wrong data. But what about a social media feed? It's way better to show a slightly old feed than to show nothing at all.
In that case, you trade a little bit of consistency to make sure the service is always available.
And here's another huge one. SQL versus NoSQL. The only correct answer is always, well, it depends. If your system needs rock-solid transactions, like for an e-commerce checkout, SQL is probably your best friend. But if you need to scale like crazy and have a really flexible data model, maybe for a site with tons of user content, then a NoSQL database might be the better choice. The key is explaining why, based on what the system needs.
And please don't forget this trade-off. Do you build the simple thing that works right now, or do you build a more complicated, future-proof system? A classic trap is to over-engineer everything from day one. A senior engineer knows that sometimes the best design is the simplest one that gets the job done today, but with a clear idea of how you'll evolve it tomorrow. So, you've laid out the principles, you've talked through the trade-offs. Now you've got to ground your design in the real world. And that means using specific, modern technologies, not just as buzzwords, but as the actual language you use to explain your design choices. Think of this as your toolbox. For all the common things a system needs, like caching, queuing, search, you should have at least one go-to tool in mind. You don't have to be an expert on all of them, but you should be able to say something like, for my cache, I'd probably use Redis. It's an in-memory store, so it gives us super low latency reads, and then explain how that fits your overall design. And this is the golden rule. Every single time you say a technology name, whether it's Kubernetes or DynamoDB, you have to immediately connect it back to a requirement. For example, I'd use Kubernetes here to manage our services. It handles auto-scaling and self-healing for us, which directly addresses that high availability requirement we talked about. See? Always tie it back. So let's wrap this all up. This is the expert mindset you want to walk in with. You start simple and you evolve the design. You build on those twin pillars of scale and reliability. And, most importantly, you are constantly talking about the trade-offs you're making. You use modern tech as the language to describe your design, and you're always thinking about what happens next, how the system will grow, and how it will handle failure. And that really brings us to the final thought. The whole point of a system design interview isn't to find the one single perfect answer, because that doesn't exist. The goal is to show that you have a mature engineering thought process. So as you get ready for your next interview, don't just think about what you would build. Think about what you would be willing to sacrifice and why. That right there is the key to technical excellence.